Okay, so welcome to the first module of the design and analysis of algorithm. And the name of this, as you can see, that is the fundamentals of algorithms. So in module one, we have four main points. The first point is the classification of the different problems and problem solving strategies, that is the brute force approach. Next, after that, we have the different time complexities, that is the linear and the logarithmic time complexities. And with that, we have the asymptotic notations, then the lower bound and the upper bound, right? And with that, we have the best case, worst case, and average case analysis. And after that, we have amortized analysis. And finally, we have the recurrences, the formulation, and solving the recurrence equations using Master's theorem. So today I will be starting the first point, that is the classification of the different problems and the problem solving strategies using the brute force approach. So to start with the algorithm point, so what is the meaning of algorithm? So the meaning of algorithm is actually a procedure. So algorithm is actually a procedure, okay, which takes any of the possible input instances and produces the desired output. Okay, so as you can understand from here, from the basic definition of algorithm, so algorithm is all about taking certain inputs and getting certain desired outputs, right? So we have some properties of every algorithm actually. So the first property is a finiteness, and then the correctness, and third is the robustness. Now the complexity of a particular algorithm, we can actually define that efficiency of a particular algorithm actually in terms of space and time, right? So we have the space, the concept of the time complexity and the space complexity, by which we actually define the efficiency of a particular algorithm. Now, before coming to the time and space complexity of a particular algorithm, I just want to explain the different characteristics of a particular algorithm. Okay, so coming to the characteristics of an algorithm, that it must take an input. Okay, a particular algorithm must take an input, and it must also give some outputs, right? So as I said at the very beginning of, while starting the concept of the algorithm, that an algorithm is all about taking certain inputs and giving certain outputs, getting certain desired outputs, better to say. So the first point or the characteristics of an algorithm is it must take a certain input and it must give some output, and it has the property of definiteness, that is, each instruction of an algorithm must be clear and unambiguous. And related to finiteness, it means that it must have, the algorithm must be of finite steps. Okay, so it cannot run lifelong, it cannot be infinite. And finally, it is having effectiveness, which means that algorithm must be containing very simple instructions. Okay, so every people must understand what it is written in every algorithm. So the instructions must be very simple in a particular algorithm. Now coming to the concept of the time complexity and the space complexity. Now, for time complexity, it can be actually defined as the number of times a particular instruction set is executed, rather than the total time taken by a particular algorithm. Okay, so it is because the total time taken, or rather we can say that the total time took by a certain algorithm also depends on certain external factors as well, like the compiler used and the processor speed, and etc. So different, external factors are also there, which actually, makes the changes. Okay, by by which we can actually say that the time taken by a particular algorithm can actually vary. These external factors like the processor speed, compiler used by a particular user. So these factors can actually affect the time taken by a particular algorithm, right? So why, or rather how we define the time complexity is that the particular, like the number of times a particular instruction set is getting executed, right, rather than the total time taken. Now one more important thing here is, in spite of these external parameters, the efficiency of an algorithm also depends upon the nature and the size of the input. Now in our example, in this case, let's consider that the size of the input is n. Okay, so the size of the input, let's say the size of the input is n. So the algorithm's efficiency, or rather the time complexity, can also be defined that the efficiency can it can actually vary based on the nature and the size of the input. Okay, now coming to the space complexity, it actually says that the amount of space the algorithm is consuming. Okay, the amount of space the algorithm is consuming with respect to an input size, and let's say the input size is again n. Okay, so the amount of the space the algorithm is consuming with respect to the input size n, and that is how we define the concept of this space complexity. Okay, now as you can see that time complexity can also be defined by the amount of time taken by a particular algorithm with respect to the input size n. Okay, so as I said, so the time complexity can be defined based on the number of times a particular instruction set is getting executed. So that is the first point we can consider. And the second point, we can say that based on, if we are considering the input size, then the amount of time taken by a particular algorithm with respect to the input size n. So over here we are considering the size of the input as n. Okay, now as you can see that both the time and the space complexities are getting calculated as the function of the input size n, right? And both of them are giving the effectiveness measure of a particular algorithm, right? Now I will come to the different asymptotic notations later on, but let me explain just a little bit over here that the time complexity is expressed with the help of some notations, and those are actually called the asymptotic notations. Okay, now those notations are actually I will write it over here. So the notations are, the first notation is the big O. Okay, the second notation is the big omega. The second notation is big omega. The third notation is the theta notation. Theta notation. The fourth notation is little o, right? And the fifth notation is little omega, right? The fifth notation is little omega, and they are represented using with the help of these, these symbols, right? So I will come to these asymptotic notations later on. Okay, but before coming or explaining these asymptotic notations, I want to explain a more important, another important topic, that is brute force approach. So regarding the brute force approach, as you can see, it is written over here that the algorithm simply tries all the possible or rather the possibilities until a satisfactory solution is found. Okay, so such an algorithm can be of two types actually, that is optimizing and satisficing. So optimizing says that the best solution, or rather, in optimizing approach, what we do is we always try to find the best solution for a given problem. Okay, so this may require finding all the possible solutions, or if a value, or if a value for the best solution is known, it may stop when any best solution is found. And considering the satisficing approach, so it says that we can actually stop as soon as a solution is found that is good enough. So even if we do not reach to the best solution, but if even if we can even we can reach to a very close value, okay, to the best solution, even if we can actually reach to some values which is actually very close to the best solution, then also we can stop in case of the satisficing approach. Okay, so there are two approaches in the brute force strategy. Now, uh, let's since I think that the best example of the brute force can be unlocking a padlock, or if you want to, let's say, unlock a mobile screen, if you want to unlock someone's actually mobile screen without knowing the exact solution or password. So this can be actually the example. Okay, so let's consider a padlock. So as you can see, so it is we are having a lock, right? We are having a lock over here which is having certain password, or some digits will be, you'll have to put. Okay, and if you are putting a certain value, for a certain value, actually it is going to get opened, the lock is going to get opened. But let's say that the padlock is having a combination of 234. So let's say the padlock is having a combination of 234, that is a correct password, let's say. And if you know the combination, it is actually fairly simple to open it, right? But what if you don't know the combination? Okay, and still you want to open the padlock desperately, then what you are going to do in that case? So one thing that could come to your mind is, what if I try all the combinations that are possible, right? So I would go with the first combination as 000 in that case. So since we don't know the combination, then what to do? If we try to find out all the possibilities, all the possible cases, then we'll have to start from 000, and then what we'll do? 001, then what? 002, right? And then and so on, like 00 up to 9 we will go, then maybe 100, and like this it will continue. Okay, and eventually what would happen is you would land up upon the code that is 2, 3, and 4. Okay, so this is the actual solution, that is 2, 3, and 4. So eventually what will happen is that it will land up on the code that is a 2, 3, 4, and this would open the lock, right? So what did you just do over here in this case? You exhausted all of your possibilities to open the padlock, right? And this exactly is what we call it as a brute force method. You are deploying all the the resources available to you, no matter how much time it is taking, but still you are trying to solve a problem, right? So as you can see over here, so if you're trying to consider all of the possible cases, right, so it is going to take a lot of time, right? So in this case, the maximum number of combinations that you could have was 1000. Okay, so there are actually 1000 possibilities you can actually go through, and going on and on, you will eventually try to figure it out that, but you do not but you do see a problem with this method? Do you see the problem? What is the problem with this? So the problem, what the thing is, momentarily you may seem that given some time, I should be able to solve any problem using the brute force method. Yes, that is absolutely true. It is true, but it is quite, limited or, time consuming, what I said, right? So in our earlier example, right, in a padlock, what we did in this case, in this example of padlock, what we did is we had 1000 possibilities, right? But let me take up another problem, and that is, let's say, solving a Rubik's cube. Now it has got 6 faces. Okay, so I think all of you are familiar with this Rubik's cube, which is having, the 6 different phases and 6 colors. Okay, so it is having 6 faces and 6 different colors, right? Now, and rather say to say, ultimately what I need to do is, is each face should have a different color. So that is the problem, or rather, no, that is how we are going to solve this Rubik's cube, isn't it? So our target is to make each and every face having the single or the same color. Okay, so to solve Rubik's cube, you cannot even start to think of how many total numbers of combinations are actually possible. Okay, so which is approximately 519 quintillion possible arrangements, okay, of the pieces that make up the cube, but only 1 in 12 of these are actually solvable, right? So as you can see, so a lot of combinations are possible over here, isn't it? A lot of combinations are possible. So in that case, if you consider try to solving, if you want to solve Rubik's cube with the help of this brute force approach, it is going to take a very a long time to solve this problem, isn't it? So given a problem which is very small, and if you have a very actually a long time, then it is fine for you to take the concept of the brute force approach and solve a problem. But if there is, if you have a time constraint and if the problem is very big, then it will be not a wise solution to consider the brute force approach and solve that problem. So let me take another example over here. Let's say uh, this is an example of a magic square, which says that we are having over here as a 3x3 grid, in which you will have to fill all the cells with certain digits starting from 1 to 9 in such a way that the sum of all the rows, columns, and the diagonals are the same. Okay, that is why we are calling it as a magic square, right? So 3 rows and 3 columns are there, and you'll have to fill the all of the cells in such a way that the sum of the rows, the columns, and the diagonals are the same. So if you're considering, then the brute force approach, if we are considering, obviously, so how we are going to fill this this cells. Let's say I fill it like this: 1, and then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, right? So then what is this what is the sum? So 3 plus 2, 5 plus 1, 6, right? So you are getting 6 over here. And then 4 plus 5, it is 9, 9 plus 6, it is 15. So again, so 15. So as you can see, so you are having different values, right? So 7 plus 8 plus 9, what you will get? 24, right? Now if you add up these values, you'll be getting 12, then over here it will be 15, and over here it will be 18, right? And if you're calculating the diagonals, then again over here you'll be getting 15, and over here you'll be getting 15 again, but still the values are not same, right? So let's try another combination. Let's say another combination is 2, 3, 4, then let's say 5, 6, 7, then let's say 8, 9, 1. If you take this combination, then what, 2 plus 3, 5, 5, and 5 plus 4, let's say it will be 9, right? So 3 plus 2, 5, and 5 plus 4, 9, and then what, 18, and then this will be 18 again, and then this will be 15, and this will be 18, this will be 12, the diagonal over here will be 9, right? Over here, this diagonal will be again 18, right? So 8 plus 6, 14, 14 plus 4, 18, right? So this is the diagonal. So again, you are getting different values, right? So let's try another combination like 4, 5, 6, then 7, 8, 9, then 1, 2, 3. Again, what we're going to get is 4 plus 5, 9, 9 plus 6, 15. And then again, over here you're going to get 24. Over here you're going to get 6, right? Over here, what, 4 plus 8 is 12. 12 plus 3 it is 15, right? Now over here, if you add, then you are getting 12. Over here, it will be 15, right? And over here, it will be 18, right? Again, 8 plus 6, 14 plus 1, 15. So diagonal will be 15. Now again, the diagonal and all of the values of the rows and columns, again, you're getting different values, right? Now let's try another one, another possible chance. So let's say 1, 5, 1, 5, 8, right? And then let's say 2, 6, 3, then let's say 4, 7, 9, right? Then what is going to happen? Then 5 plus 1, 6, 6 plus 8, 14. So you are getting 14 over here. Then 6 plus 2, 8, 8 plus 3, 11. So you're getting 11 over here, right? Then over here, you're going to get 20. Now over here, you're going to get 7, then 18, then 20 over here. Then for the diagonal, you are going to get 18, and over here, the diagonal is going to get, you're going to get 16, right? Again, different values. So in this way, you can actually try a lot of times, right? A lot of times you can try. So it will be, a lot of possible combinations you can try. So ultimately, you will reach to a certain state, like when you will be, entering these values like 8, 3, 4, and then over here you'll have to enter 1, 5, 9, and 6, 7, 2. Right. Now, if you add, then 8 plus 3, 11, 11 plus 4, that is 15. And then 5 plus 1, 6, 6 plus 9, again, you are going to get 15. So 6 plus 7, 13, 13 plus 2, again, you are going to get 15, right? Now, 8 plus 1, 9, 9 plus 6, you are going to get 15. So 5 plus 3, 8, 8 plus 7, 15. And 4 plus 9, 13, 13 plus 2, 15. Now, if we add the diagonals, then 8 plus 5, it is 13 plus 2, 15. And over here again, 6 plus 5, that is 11, 11 plus 4, you are going to get 15. So this is when you will reach a certain state where we can actually consider this as, a magic square, right? So if I say that this is, try to fill up this 3 cross 3 grid with certain values, which will be having the summation of the rows, columns, and diagonals the same. So what we are going to do? So if you follow this brute force approach, so then if you will be having 32,000 different combinations, right? So in this way, if you try to fill up, like starting from like this, so you can have actually 32,000, possible combinations to get the ultimate answer, right? But still, it is, if you, as I said, so using the brute force approach, a problem can be solvable. But sometimes it may happen that brute, even with the brute force approach, the problems are actually not solvable. So but it is for sure that if you are using brute force approach and if the problem is not solvable, then with any other technique also, the problem, that particular problem will not be able, we will not be able to solve that problem, right? Because brute force approach actually checks all of the possible combinations, isn't it? So I will give you another example where even with the help of the brute force approach, it will not be able, actually will not be able to solve that problem, right? So this is actually over here, as you can see. So there we have 32,000, combinations. After, iterating 32,000 times, we'll be able to, maybe we'll be able to reach a certain state where we'll be getting the answer like this, right? So initially what we had over here, we had only 1,000 combinations, right? Over here, it is 519 quintillion combinations. Over here, we have 32,000 combinations. So all of this, as you can see, it is very time consuming task, right? Now I will show you another kind of problem where even using the brute force approach, you are not going to solve that particular problem. So the problem is actually very simple. Instead of taking 3 cross 3 grid, if you are taking a 2 cross 2 grid, then, and if you are asked that to fill the cells with certain digits, which are starting from 1 to 4 in such a way that sum of all the rows, columns, and the diagonals are same, right? So it doesn't matter in which combination you take, like 1, 2, 3, 4, then maybe over here 5, 6, 7, 8. Not sorry, over you cannot write it, take 5, 6, 7, 8. So you cannot take 5, 6, 7, 8. So up to 4 it is said. So let's say you take like, or like this, 4, then 3, then 2, then 1, right? Then 1, then 2, then 3, then 4. You can take any possible combinations, right? You can take any possible combinations, but this problem is actually not solvable. Okay, this problem is actually not solvable. So even with the help of the brute force approach, this problem is not solvable, right? So this is all about the concept of the brute force technique, where we solve a particular problem by trying all the possible cases, okay, by trying all the possibilities, okay, until a satisfactory solution is found, right? So this is all about the brute force approach. So if you have any query related to today's session, then you can ask questions from this.